Good morning, my dear student. I am presenting lecture number 2, wave mechanics, that is quantum mechanics. Myself, Dr. Kapil Kumar Sharma. Here, first of all, I will discuss the previous lecture. In the previous lecture, we have discussed some phenomena like black body radiation and what is quantum mechanics. In quantum mechanics, we can understand on the basic of some phenomena like a black body radiations, Stephen's law, Rayleigh-Jean's law, and Wien's law. After all the expression, we observe that black body radiation coming from the body cannot be explained by some scientists. After, in the second lecture, we'll discuss what is the shortcoming of the classical theory and explain on the basis of Planck's. Here, the content of the presentation like Planck's law, with derivations, Bohr quantization rule, wave particle duality, de Broglie wavelength, and matter wave. These are very important expression. These are very important phenomena. These are very important rules for quantum mechanics, because on the basis of these quantum mechanics, all the problems can be solved by this parameter. Here, first of all, what is Planck's law with derivation? Max Planck explained this phenomena by proposing that energy exists only as a discrete unit. That is, energy in that associate with the oscillation of charge within the atom and molecules is quantized. It can only take on the whole number of multiple of some minimum value. As per given C, we previous article and previous lecture we see that the some phenomena black body radiation come from the body cannot properly explain. Wien's law is only explained for shorter wavelength. Rayleigh-Jean's law is only explained for longer wavelength, but cannot predict exactly what is the parameter of this value. Here, because experimental value and theoretical value does not matching, Planck assumed that according to Planck, some energy associated with the oscillation of charge within atom and molecules is quantized. Quantize What is the meaning of quantization? That is discreteness. It is not a continuous. Hence, the minimum energy of an oscillator can be determined by taking the product of Planck's constant and frequency of, oscillator. This theory became known as Planck's theory of hypothesis. That was a basic phenomena. Here, the Planck's quantum hypothesis may, when body emit or absorb light of frequency nu, either f, it can emit old amount of energy. It is because it is some special, it emit a step, that is E is equal to NHF. That is N is always 1 in this value, that is H into multiple of frequency. The energy per unit frequency, the Planck's constant, the value will be 6.63 10 to the power minus 34 joule second. Here in this diagram, we can see that these are the frequency curve and these are say radiation intensity. If we observe, the quantum mechanics phenomena cannot be explained properly by classical idea like a Rayleigh-Jean's law, like a Wien's law, but it can explain on the basis of Planck's theory. Here again, Max Planck's law of radiation. How can he derive the relation? The explanation of the complete black body radiation was explained by the Max Planck in 1900 based on the quantization of energy. He assumed that radiation chamber of a black body beside radiation is a field with a simple harmonic vibration, because energy come from the body and incident on the it, they have a small vibration. They have a small vibration of energy like a molecules which oscillate with all possible of frequency. Here the total number of oscillator per unit volume, that is 8 pi h nu square du nu upon cq. As per according to the Planck's constant, according to the Planck's idea of quantization of energy, an oscillator cannot radiate or absorb continuously, because that is very important point. Not continuously. Energy is always in discrete manner, but it does not it does in term of nh nu, where n is equal to 0, 1, 2, 3 as a like a integer. Because some energy is coming, that is nh nu, another energy coming 2h nu, another energy at 3h nu. There is a small interval of energy, as energy is not a continuous manner. Now according to the Maxwell-Boltzmann distribution law, the number of molecules, like if number of molecules n, that is n minus 1, n minus 2, n minus 3, n minus 3, exchanging the energy of 0, h nu, 2h nu, 3h nu respectively inside the black body. Then total number of atom oscillate by the frequency is given by like n is equal to n1 plus n0, n1 plus n2 plus n3, and these are the Maxwell-Boltzmann distribution law. N is equal to n0 e to the power h nu upon kt. These value will be defined n0, we putting this value again, n1 n0 is common, 1 plus e to the power h nu upon kt, e to the power 2 h nu upon kt, e to the power minus 3 h nu upon kt, and so on. Again these are the arithmetical progression. Okay, like this is n0 is equal to under root 1 minus e to the power h nu upon kt ki power minus 1. These are the equation number 1. Here these are the number of atoms in a total discreteness, because energy is not a continuous. If energy is continuous, we cannot summarize of the energy. Hence, the total energy E of the oscillator having fundamental frequency nu, because we know that E is equal to h nu, that is 0, like 0, h nu, 2h nu, 3h nu, and so on. These are the number of energy levels. And these are calculation by equation number 2. And again, equation number 1 and 2 we solving, therefore sum of the average energy E of the oscillator having fundamental frequency is given by E is equal to E summation of that is E upon n, and solve this equation h nu upon e to the power h nu upon kt minus 1. This equation has become 3. Hence the energy density of the oscillator having fundamental frequency in the narrow range of between nu and nu plus delta nu is given by, we put in this value 8 pi h nu square dV upon cq. These are the energy density, and these are the calculation by equation 3, h nu upon e to the power h nu upon kt minus 1, and solve the equation. And these are a very standard notation, standard formulation of Planck's law. These radiations formula can properly explain on the phenomena of black body radiation. These are properly explained by the black body, and these are very important phenomena. From experimental data can be matching by this figure. Here we can also some verify of this formula by this value. If nu is equal to if nu is equal to c by lambda, that d nu is equal to minus c d nu lambda upon d lambda, that is differentiation. In the above equation we get nu energy radiation in term of wavelength, that is 8 pi sc upon this value. That is equation number 4b. This is another form of the Planck's radiation formula. Here we have a two case, because classically we have no any experimental suggestion. Like classically we can only explain for a shorter wavelength as well as for a longer wavelength. In classically, if we have a shorter wavelength e to the power h nu upon lambda kt greater than 1, then I lambda d lambda in term of 8 pi sc upon lambda, and these are verified by Stephen's law. These are C1 is constant, C2 this is constant, or this is expression for a Wien's law. Another in case of longer wavelength, because Rayleigh can be explained by only for longer wavelength. Hence, if e to the power h nu upon kt is very greater than to the 1, less than to 1, from Planck's law of radiation we have this formulation and apply the binomial expression. On neglecting the second term and higher term, we can represent I lambda d lambda 8 pi h kt upon this value. Thus, we can say that Wien's law and Rayleigh-Jeans law are the special case of Planck's law. These are very important expression. Here, all the micro level mathematical calculation I have given to in my notes. But in this presentation, we only consider how to derive a Planck's radiation formula. Here, by this expression, we can understand properly how the Planck's radiation theory can be explained on the black body of radiation. Here, these are the conclusion of the Planck's theory. According to the Planck, these are very important for your examination point of view. Number one, different atom and molecules can emit or absorb energy in discrete quantity only. That is very important point, discrete quantity. Like a parameter, energy is not a continuous. The smallest amount of energy that can be emitted or absorbed in the formation of electromagnetic radiation is known as quantum. That is E is equal to nh nu as per given last slide. Number two important conclusion, the energy of radiation absorbed or emit is directly proportional to the frequency of the radiation. These are the parameters. Hence, meanwhile, the energy of radiation is expressed in terms of frequency, that is E is equal to h nu. These are very important expression. If we calculate h, the dimension of h, you can see these are the dimension of angular momentum that is associated only by a wave. E is the energy, h is a Planck's constant, and nu is the frequency of radiation. These are the parameters. Here again the some phenomenological change, because after the Planck's they have a certain disturbance in science and technology and certain possibility to new area of research, like energy is not a continuous manner at the time of classical, but energy is always discreteness in term of quantum mechanics. As per Bohr quantization rule, we can understand by this phenomena all the possible circular orbit allowed by the classical theory, the electron are permitted to the circulate only in these orbit in which the angular momentum of electron is integral multiple of h cross. H cross, that means we can also write in 2 pi h cross, where h is the Planck's constant, therefore any permitted energy. Hence, these are the wave nature. These are the wave nature. These are the node, anti-node. We can die. Then n is equal to 1, 2, 3, 4. They have a node. These are anti-node 1, 2, 3, 4, 5, 6. And these are the energy. If we see the diagram, as per Bohr theory, they have a certain theory by the electron transition. We can see that the electron revolve like this path. These are path. Is not a properly circular. Electron are revolving like this, like a laser knot. We can see. And these are allow energy band, like allow orbit constructive interference. If one is circumference 2 pi r, that will be n into lambda, that is wave represented. A wave is a combination of wave, just a simple harmonic vibration. And these are the parameter. It's just like a forbidden energy game. This is not a possibility. And these are the exactly diagram. Here we calculation by this, where L is the angular momentum, m is the mass, v is the velocity of the electron respectively, and r is the radius of permitted orbit, and n is the positive integer called principal quantum number. The above equation is Bohr famous quantum condition when the electron of mass m confined to a move in a box L length L with the velocity of v, that lambda is equal to h upon mv. This is the famous relation of de Broglie. We can also the particle nature, wave nature understand by this relation. Lambda is equal to the wavelength of associated by the wave by the particle, that is lambda is equal to h upon p, where p is equal to lambda by h. Again we put the value. These are the important expression for a Bohr quantization rule, and that are very important for your examination point of view. Here these are the basic property of is 10 plus 2 level. We can understand wave particle duality. As we name in the figure, like a wave particle duality, like a wave, it a disturbance of medium, particle like a classical particle, and duality, that has a dual nature. The particle and wave have a dual nature. The behavior of electron do not allow the observable as a particle and wave. The two side of nature of the electron is known as wave particle duality, because sometimes particle behave as a wave and sometimes particle behave as a particle. So particle is a wave and wave is a particle. We can understand properly in simple language. So the property of particle behaving as the property of wave behave as a particle we can understand, although these are de Broglie wave, because quantum mechanically we can see the particle are moving, just associate a wave, but you can see only one scene. If like a particle are seeing, that is you cannot see on the wave. If you see the particle, you cannot see the wave. If you see the wave, you cannot see the particle. So these are the energy in NH nu. These are the concept of wave particle duality. After that, the on the basis of Bohr quantization rule and wave particle duality concept, de Broglie. De Broglie is a famous scientist as in the time of quantum. De Broglie derived his equation using established theory, because particle nature and wave nature, both nature are present on the basis of Einstein's famous relation like E is equal to mc square, where E is the energy, m is the mass, and c is the velocity or speed of light. They using the Planck's theory of we have because we have a two relation like E is equal to mc square and E is equal to h nu. On the basis of two relation, we can calculate the de Broglie wavelength by the system. Here we have a de Broglie wavelength lambda is equal to h upon p, that are very important expression for this calculation, and where p is the momentum in terms of kinetic energy, we can also represent this figure. And this is very important aspect for your numerical point of view, where lambda stands for wavelength and particle h stand for Planck's constant, P stand for momentum. These are another important notation for numerical point of view. You can also other useful expression for a de Broglie wavelength, like if a non-relativistic particle, you can understand non-relativistic. That means velocity of particle is very less as compared to the c. See the speed of light. This is expression lambda is equal to h upon twice of m into kinetic. These are the all level of limit. Again, if accelerated potential, if the particle of mass m and charge q accelerated through the potential difference v, then lambda is equal to, we can put this value. If h is put 6.63, m mass of the electron, these are the skip in angstrom, 12.23 angstrom under root applied v. These are the applied potential. In case of relativistic particle, we can apply this formula. So these are the basic formula for your numerical we can calculate. If you want to see calculate, some the images are observed like E is equal to half mv square. These are the kinetic energy, and E is equal to qv. Hence lambda is equal to h upon p. Then here these are the expression for very important for your examination point of view. If we calculate the de Broglie wavelength for relativistic, we use this formula. If we calculate the accelerated charge particle, like this formula. If we calculate this formula, this formula. These are the basic formula. We can calculate all the problems related quantum mechanics. Here, after that, because we understand on the basis of this theory, like particle nature, wave nature, we can understand and also calculate the de Broglie wavelength for this parameter. After that, what is matter waves? Matter wave is some conceptual, they have no idea because particle are moving and associated matter waves. These are all important parameter, but we can only experiment as your examination point of view and university syllabus. Matter wave are center part of the theory of quantum mechanics because particle are moving associated matter. Being an example of wave particle duality, all matter exhibit the wave-like behavior. For example, a beam of electron can be diffracted just like a beam of water waves. They have some characteristic of this wave. According to the de Broglie wave, a moving material particle sometimes act as a wave, sometimes act as a particle. The wave associated with the moving particle is called the metal wave or de Broglie wave, and propagated with the wave packet with the group velocity. They have some property. Matter waves have represent the probability of finding the particle. In the entire region, where is particle? We can calculate on the basis of this parameter. Number two, matter wave are not electromagnet in nature. These are different type of waves because you know what is electromagnetic wave? Electromagnetic wave associated with the charged particle. Here De Broglie or matter wave is independent of the charge of material particle. It means that matter wave, de Broglie wave associate with every moving body, whether charged or uncharged. Here, you can also see like a big particle or small particle and calculate the de Broglie wavelength. Practically, observation of the matter waves is possible only when the de Broglie wavelength is order of size of particles. Number 5, electron microscope work based on the de Broglie wavelength. That was the famous experiment, that is transmission electron microscope. You can see entire region of the atoms by this experiment. The phase velocity of the matter wave can be greater than to the speed of light, because there is another expression for phase velocity and group velocity, but as per university level there is no area, but you can understand by book and previously for another discussion. Matter waves can propagate in vacuum, hence they are not a mechanical waves. Number of de Broglie wavelength associate with nth orbit of electron, because one orbit you can see by last slide, that is 2 pi r is equal to nh, and these are the n number of orbits. Only these circular orbit around the nucleus of the are stable, whose circumference has integral multiple of de Broglie wavelength associated. These are the basic property of matter waves, because matter wave is a central part of the quantum mechanics. Thank you very much. These are the basic phenomena, basic law. We can understand quantum mechanics by this expression. Next slide, we will present the another waveform of the wave function and another slide that are very important for your examination